with BCIT. So for those of you who are not too familiar with BCIT, we have a somewhat unique position in the post-secondary sector as the only polytechnic institution with provincial mandate to support workforce development. We have around 50,000 students. We provide advanced education to support a wide range of industries across BC, from trades to healthcare, engineering, energy, business, transportation. And we graduate more students in computing than any other post-secondary institution in the province. BCIT is also a leader in virtual simulation and multimedia development for education, and we're fortunate to have an outstanding specialist team in our Polytechnic Research Institute for Simulation and Multimedia. They support our faculty and students with virtual and augmented reality and emerging technologies. And you'll hear from several of those folks this afternoon as they share some of the exciting work that they're doing. I'd also like to thank all of our speakers for joining the webinar today and for taking the time to present. And I'd like to thank Brian Hosier, the director of our Learning and Teaching Center, for his support for this webinar. All right, so to kick things off, I'd like to introduce a good friend of mine who I'm sure most of you know well, Dr. Patrick Pennefather, who's an assistant professor at UBC and with a co-appointment to the Master of Digital Media program at the Center for Digital Media. He'll be joined with June Zhang, a graduate of the MDM program who was the student project manager for the Holocopter initiative. I'm looking forward to hearing the presentation. Patrick and June, over to you.
Awesome. Hi, everyone. My name is Patrick Pennefather, as was mentioned by good colleague and friend James. Super happy to be here. Today we will be presenting on a project that was actually initiated by James and the team at BCIT in aerospace engineering. Before I do so, I want to introduce my co-presenter, who is also project manager and in many ways team lead of the project at the Center for Digital Media, June.
Hello, everyone. It's my pleasure to be here again. I think I was here a couple of months ago, and really happy to introduce the project to you guys. When we did the project, I was the sort of graduate student at Center for Digital Media. I'm currently at JBC as an instructional designer, working on a few VR projects as well, and also like you guys, converting course to online because of COVID.
So the objective of our meeting today is to present the Holocopter project, which was a mixed reality project using Microsoft HoloLens, as a use case that encapsulates three broad areas, which is project-based learning and development of a research artifact, the teaching and learning which it supported, in addition to supporting a research initiative that was initiated by James Rao. Our agenda, we're going to describe the Holocopter as a project. We're going to discuss it as a use case for a unique type of collaboration that we are hoping will continue to inspire collaborations like this that don't necessarily create silos in a way by siloing out research and teaching and learning, because we see this project as a really good example of something that can bridge the two. Following that, we will also be facilitating Q&A for James will. And June, take it away.
Before I introduce the team members on this project, I just want to briefly mention why we're doing this as well. This is a typical CDM project when I was a graduate student, which is 3 months. So basically, we were full-time on this project, but also taking a few courses at Center for Digital Media. So when this project came to us, Patrick was speaking to us, about how this project is going to look like, what kind of skills requirements are there from the client, James and Rosario. So then we put together a team. I was, the project manager for this project. We have two UI UX designer, John and Lauren. They're fantastic. They're very, very experienced. John is currently an instructor at Emily Carr. So they have tons of experience in design. And fortunately, we have 3 developers in this project. Frank was sort of the lead of the developer team. Tommy has a lot of game experience, and he was really helping out, in terms of interactions and thinking about how things could work in this project. And Patrick was fantastic. I think he's probably in Microsoft or Google right now. He did a lot of multi-person network, the kind of stuff. And he also helped us publishing this application in Microsoft Store, which is super rare in my experience. This is really a exciting project. And of course, Patrick has been along the way helping out and guiding us.
So let's play a video and give you a context of the entire project. And then June will continue with lessons learned from different aspects of the project. Good, I took off computer audio. Should be good to go.
Our group consisted of 2 programmers from CDM and a programmer from SFU's undergraduate computer science program. Our team also consisted of 2 UI and UX designers and a project manager. The project aimed to translate an existing desktop application into a Microsoft HoloLens application for the BCIT Aircraft Maintenance Engineer program. The existing 2D desktop application is an interactive 3D model of an Airbus AS350 helicopter rotor that can be accessed through a web browser on a computer or a tablet. The user is able to manipulate controls to affect the rotor. The collective pitch of the blades, the cyclic pitch of the blades, the speed of the rotor, visibility of the airflow, and display controls could all be manipulated to help students understand what these controls do to the flight dynamics of a helicopter. HoloLens is a relatively new technology that enables users to experience interactive 3D digital sound and graphics, or holograms, overlaid onto real-world space. In the broadest sense, the problem we tried to solve was onboarding a client to a new technology, namely Microsoft HoloLens. A secondary problem was developing a HoloLens application and discovering the unique UX and UI considerations in working with HoloLens and holograms. A tertiary problem was to explore the use of a multiplayer function in a HoloLens experience. Our development process started out with research. The tech team engaged in research on HoloLens deployment, the import of assets, and how to program interactions. The UX and UI team studied what work had been done previously and researched best practices in designing holographic experiences. The team created an MVP, or minimum viable product, within the first 2 weeks of the project start by importing the existing assets and layout into a HoloLens application. The MVP was tested and user feedback was captured to create a backlog. The backlog was groomed as a team and new prototypes were produced and user tested in bi-weekly intervals. Our group consists of a menu can be found below you. The application was created in partnership with practices for teaching and learning. Helicopter rotor head simulation. Welcome to the Airbus AS350 helicopter rotor head simulation. This application is part of a larger BCIT project titled Effective Mixed Reality Practices for Teaching and Learning. The application was created in partnership with BCIT and the Center for Digital Media. You can use voice controls. The voice command menu can be found below you at your waist level. Use your head to move the gaze cursor to the menu, and the commands will pop up. For example, if you say, make bigger, the rotor will increase in size. If you don't remember what to say, you can always look down to see the voice command menu.
Make bigger. Make bigger. Make faster. Make faster.
The final solution proposed a very clean UI that incorporated voice controls instead of menus to encourage 3D viewing and movement around the rotor. UI elements were positioned out of the direct line of sight of the user or presented as translucent to give the main rotor presence. The team worked very hard to polish the tap and drag interactions necessary to manipulate cyclic and collective controllers.
Make smaller. Make smaller. Show airflow.
This project was, as I mentioned, was a trifecta of different aspects of production. The project-based learning environment was an important one for Master of Digital Media students, as it's part of our learning outcomes for different project-based courses that we offer, to give our students as close as we can to the real experience of project development. Through that iterative process of prototyping over 12 weeks, the students learn a number of different types of outcomes, including collaboration with the client. And in this case, our real-world client was BCIT. And through James, as I mentioned, who brought the project on board, and also Rosario from Teaching and Learning. The outcomes of that project are our lessons learned, and these were also put into extensive documentation that the team delivered. I'll now pass it back to June, who will talk about some of the lessons learned.
Thank you, Patrick. Before I actually specifically talk about UI UX or any aspect of the lesson learned, I just want to give you sort of a sense of the scope of the project. I think at the beginning, the scope of the project, Patrick, correct me if I'm wrong on this, is sort of translating the 3D desktop application, because BCIT has that desktop application already they're using, and they wanted to transform it into a 3D environment. So in a sense, we're working on something that exists already, but in another sense, we're working on something we don't know a lot about. Because HoloLens was a different thing, and back then they were using the first generation, now they have the second generation. So lots of the interaction of programming, or even the field of view when you put HoloLens on, it's quite different than a typical VR project that we did in the past. So just looking at those, I think that creates lots of challenges for us. First, we have to translate the existing features to HoloLens, and we also sort of have to transform it in a way that is user-friendly and create a good experience for instructors and teachers. And one of the barriers is really thinking about how they're going to use it, right? Are they able to, do the little pinch, or how they're going to use it? I think there was a lot of challenges on that as well. And I mean, we didn't promise to build the multi-person network. And I remember Patrick and us were having like, let's just don't promise that to them. But toward the end of the project, we're actually able to spend 2 or 3 weeks around, how trying out and, just working on multiplayer function. And I have a really good story to tell you later on. And also, like I said, we published this into the Microsoft store, because but it's a lot of work too because you have to sort of meet their standards in order to publish it. Yeah, so and then of course with all the documentations, so that BCIT could take it over and sort of internally build it. Patrick, do you have anything to add before I talk about the lessons learned?
No, that was brilliant. That was brilliant. Keep going. A lot of what we talk about in terms of project-based learning environments is to be careful how much you promise. And so this is always the challenge when you're developing with new technologies at the time. HoloLens had already been somewhat established, but in terms of students who are just getting onto it in terms of development, it was new tech in that way. So that tale that June mentioned, awesome to underpromise, and they did overdeliver. So,
yeah. And I think that that's actually the biggest lesson that I learned too. Like, I think I came up with a slogan for that: underpromise, overdelivery. So I should put that somewhere in my bedroom or office. Anyways, so let me talk a little bit about the lesson learned in UI and UX. So there are 3 points here that at least we listed on the PowerPoint. Break down everything, limited field of view and 3D UI. So very specifically, when we look at the 3D desktop application, we look at, there's a lot of technical jargons in this program, right? There's like router view, cyclic control, collective control. If you're not someone who's in the subject matter, it's really hard to understand. And part of this project starts with just really understanding what's the parts and pieces in this application. So from a UX perspective, we did spend some time, going to BCIT, visiting the instructors and the instructional consultants, and having a separate interview with the instructor just to say, how do you use this? How do you teach it? What do you need to teach it? And we came with a big chart saying, basically in the chart it says, it's from the instructor perspective. In order to teach this, I need these functions to work. In order to teach another concept, I need the other things to work. And that chart becomes our sort of project backlog, because we have to sort of determine what's the backlog for us and what are the functions that we should focus first and deliver eventually. So it's really, like I said, breaking everything down, the camera view, router speed, airflow, drag and reposition the routers and rotate it. And with that, we also sort of added a lot of stuff. And that's a great segue around technology. HoloLens was really new in the sense that it's not like a VR that you have controllers, right? You can control and point certain things with a laser beam or grab something with the hands. It's really about using the voice control and within the limited field, how your hands and gesture work. So our development team spent a lot of time just learning, the tutorials on Microsoft's website, and even emailing them asking like, okay, is this how HoloLens work or not? So with that, we added lots of voice control that you see in the video, right? I think at the beginning, the voice control was sort of in front of you, and it's sort of like presents lots of information because you have at the same time looking at the voice control and looking at the router itself, and and also control the cyclic and collective router. So there's a lot of changes from a tech side and the design side, and also think about the gaze, right? Because it sort of follows your gaze, and your gaze is basically the cursor. So those stuff are really difficult. And the other thing around network is, we had a challenge about how we're going to do this multi-person network, because the idea is that when the instructor put the HoloLens on, the instructor will be able to broadcast what he sees to other HoloLens in the classroom. So that was a big challenge too. Like, I think normally people would design a good UI and it take a lot of time. Because of time constraint, we really just use the voice control. So in the documentation we gave to ECIT team, it says, basically you have to use voice control to start multiplayer mode or exit multiplayer mode. The other thing I would mention is the sort of project management side of it, because we have 2 designers and 3 developers, and that sometimes creates a little bit of sort of design or tech conflicts. At the beginning, because we didn't do the project, we didn't know HoloLens, we didn't know how it works. So it was sort of driven by the tech team. The tech team says, okay, this doesn't work, this should work this way because, blah, blah reasons. And I think there was a big conflict because the designers feel like, okay, what I'm gonna do here, I can't really help because it all doesn't work. And I think as the project goes, I think people start understanding the flow better, understanding how HoloLens better. And we have, constant meetings around, how can we do this better as a team, improving the process. And I think things started getting better, the pipeline and process getting better when people started caring and having a more standard process of importing the assets and creating interactions. Small things like just simply asking what format of the assets do you need helps a lot for the tech and the design team already. We actively involved the clients in testing and in giving feedback, and it's a weekly schedule for us. So we basically do our stand-up on Monday, and we do the design sprint during the week, and we deliver a prototype around Friday. We usually invite James or Rosero and a few other members from ECIT to come over and visit and experience it, and we did some user testing with the instructors as well. So yeah, so I think that's all I want to share. Patrick.
That's great. No, that's perfect, June. And on one of the last slides, it said client management, and in this case, it was clients management. So because it's interesting with a project like this, and this brings into the use case for collaboration that I wanted to speak to. So students on the MDM team learning tons about project development. All of this is helping them because they come to our program with similar to BCIT in many ways with, I am studying in this capacity because I am wanting to transition to a particular digital media industry. And I know that's broad when I say it. So this can be anything from the environments of teaching and learning in which June has transitioned into, or a gaming industry, or a mobile development industry. So that's the first thing to understand about why this project was really useful for each of the team members, because they could then take those skills, and as they moved into graduating and going into internships, they could better target how those tools and skills that they learned could be applied to a real world application and job. The other aspect is the teaching and learning, and this is important to say in this particular case because in the beginning, it was clear that we couldn't just develop something for the students. It also had to be simultaneous or parallel development for the instructors, because ultimately the instructors also had to embrace the technology and be able to troubleshoot when the students were having challenges and troubles. So this is an important thing to consider when developing any technology that is meant for a classroom. We cannot just assume that we're going to build something that students will use. There has to be the entire ecosystem of teaching and learning that is on board and part of that team. The other aspect, which maybe James will have time to talk about, is that this research object that we created also became for research. And this particular research was useful in order to understand in a kind of an A/B testing type of way, which I think was the way that James went into it. Feel free to interrupt, James. In terms of, well, what is the difference when students learn in a more conventional way about helicopter rotors, and how is there any difference I know this will get into the quantitative aspect versus qualitative. Is there any difference when learning with the Microsoft HoloLens for students that do engage with it? So I just wanted to mention those three aspects as we move towards closing and towards Q&A. Thank you so much for your time, and thanks, June.
Fantastic. Thank you so much, Patrick and June. That was really exciting to hear. Patrick, I think important to note as well that this project was a collaboration between 4 institutions, BCIT, Center for Digital Media, UBC, and SFU. And this project also was recently awarded with an award of excellence from the Canadian Network of Innovation in Education. So quite an achievement, and congratulations on that to you and to the whole project team. Just like to open it up to the floor. If anybody has any questions for Patrick or June, I'd love to hear them. Question in chat from Rob. Are there any lessons learned for scaling these types of projects up? Was there consideration for developing a reusable framework that could apply to other projects?
In this particular case, we were very tightly focused on delivering something that was useful and that could be scalable to the team of teaching and learning at BCIT. So after we hand off and try and answer and integrate Kyle's question into it as well, from the moment the week that we met until we delivered, it was probably 12 to 13 weeks of development time. Throughout that time, we did have some mentorship from Charla at Microsoft, who is one of the team leads at the time of the Microsoft HoloLens. So there was a little bit of integration, and our attempt to, in terms of my job a little bit at the Center for Digital Media and others, is to try to find mentorship where that mentorship can, within our network. So essentially, who do we know at Microsoft who might be able to help or support the development and to give feedback? So Charlotte was really great in terms of the user experience, particularly of the Microsoft HoloLens, and challenged the team to think about that as they move forward in the co-construction. Might have answered both, I'm not sure.
Thanks, Patrick. Another question from Kyle. Kyle is curious to hear more about the I think he means Microsoft HoloLens onboarding process. Mm-hmm. It seems like they have the technology and the BCIT project team needed to demonstrate how the HoloLens would be ideal. What was the timeline like from MS pitch to developing the final product? Yeah,
so that was, James, what I tried to answer in the last one. I tried to integrate that both, so 12 to 13 weeks. And essentially that onboarding goes a little bit like this, Kyle. Microsoft HoloLens development. Go students! A little bit like that, little bit, right? Part of that challenge, and June can speak to that, is to ensure and facilitate an environment in which we, and by we I also mean James and the team, we propose a client brief, essentially a statement of intention with a project, and we hand it to the students to decipher, to go back and forth with the clients in order to be able to, probably within 2 weeks, ideally, sometimes it takes longer, 3 weeks, sometimes longer, to find agreement and alignment on a direction. Other questions?
Any other questions? Oh, okay. Thank you, Patrick and June. Really appreciate your presentation. That was outstanding. Moving along, I'd like to introduce Daniel Block. Dan is our learning technology specialist in the Learning and Teaching Center at BCIT, and I've had the privilege of working with Dan for the past several years. Dan has been very engaged in our virtual and augmented reality program at BCIT. He works with our team in PRISM, as well as in our educational technology services team. And I think just speaking more about research, and Patrick mentioned that the Holocopter initiative had a strong research component. You know, we're big believers that it's important to study the implementations of our tools and techniques in practice. in part just to understand if they're effective or not. And Dan and his colleague Jennifer, who will be speaking later this afternoon, have really taken that on as well. And so you'll hear more about that. I'd like to introduce Dan. Over to you.
Thanks, James. Always happy to hear the praise. Yeah, my name is Dan Block, and I'm going to be talking to you about one of the multiple projects we have going at BCIT in the virtual reality realm. That is called Be the Beam. I'm just going to share my screen here. Hopefully you guys can see this. All right, it should be visible. Can you guys see my screen? Can I get a yes from someone?
Yep.
All right. Yeah, so we're going to go through a few things about Be the Beam. I'll give you a rough timeline here. What is it? What is Be the Beam? Why does it exist? And why did we use virtual reality? And then I'll go through a bit of a demo and then answer any questions you might have. So what is it? Excuse me. So Be the Beam is a VR software development project. It's being predominantly led by the Learning and Teaching Center, but its destination is the Medical Radiography program at BCIT. So we're working very closely with Francine Anselmo, one of our favorite instructors in the medical radiography program, to create this project. And what Be the Beam does is it effectively teaches the physics of X-ray production through a narrated journey. I always liken it to, if someone's familiar with the children's program, The Magic School Bus. I've taken a lot of inspiration from that that show in my childhood into creating this piece of software. So Be the Beam effectively follows the journey of an X-ray beam. So from creation, actually technically we start in the X-ray room, then we move the user inside the equipment itself, inside the X-ray tube and the collimator apparatus. And then finally, we move down through the patient that is being imaged, and then into the digital receptors, which then produce an X-ray image for us. So the why. We often start our projects in the LTC with a problem. We don't like to start with a piece of technology. So the problem that came out of medical radiography was that their students were struggling heavily with the physics of X-ray production. And I don't want to say it to embarrass the program, but the failure rates in these particular courses were quite high, nearly 50%. The instructors had basically exhausted all possible teaching methods to get these students to understand the physics of X-ray production. And a lot of the problem comes from the fact that kind of by requirement, medical radiography students are biology students. They're biology majors typically. So their physics can be somewhat lacking at times. So I want to talk about why VR, not the airport, a little bit. We've successfully been running VR inside classrooms at BCIT for about 4 years now. And I personally have quickly learned that when you're trying to teach a subject that is very spatial in nature, that involves understanding how objects work with other objects, specifically in human anatomy, it can be very, very beneficial. So a lot of our early implementations did focus on bones inside the skull specifically. If anyone is familiar with the sphenoid bone, feel free to Google it quickly. I should have grabbed a picture. But the sphenoid bone is a very complicated bone that sits effectively just behind your eyes and informs parts of your temple and close to your cheekbones, but not quite. And students were struggling with this in medical radiography programs as well. So we implemented VR as a way to see if it helps. So we had a VR human anatomy simulator where students could manipulate the sphenoid bone and see how it fits into the skull, how it fits into other bones of the body. And the results were really good. And the results were so good, in fact, that we decided that we needed to step away from the qualitative response of our students giving us, hey, this is really great. And we needed to move into the quantitative. So that launched a 3-year VR efficacy research project, of which we're in year 2 of 3 right now. I can't give you definitive results at this point in time, as our control groups are not quite finished running. They'll be finishing up in the January term. But the early results are dramatic. The ability of students to reproduce and understand concepts in 3 dimensions is quite astounding, especially since we're only giving them about 5 minutes in VR. So we took these concepts that we knew or we felt were working with our current students, and we thought, can we apply that to the physics of X-ray production? And that's where this project came from. So, oh, did I move too far ahead? I think I did. So I want to give you guys a quick kind of a demonstration of where this project is at. It's not finished. We're expecting delivery of Be the Beam to be in 2021, but I'd say we're a good chunk through it. So let's see here. Let me just switch to my VR here. Hopefully you guys can see that. And let me just get my VR headset ready for you guys. So what you should be seeing, and feel free to yell at me if you can't see it, is an X-ray room. So this is our current implementation of X-ray equipment. So the students have the ability to kind of tour around a room and understand the facility. Initially, we hadn't intended this to be some kind of definitive tour of an X-ray room, but with the COVID-19 situation, the ability to put a headset in our users' hands at home and have them be able to tour an X-ray suite is quite beneficial. We don't need to fully gear everyone up in PPE to see these objects. But effectively, we start here at the control panel in the simulation. And the control panel is behind this lead shielded glass where an X-ray technologist would be standing when they give you an X-ray. And there's some narration happening right now that you guys can't hear, but effectively it's talking about different parts of the X-ray room. It's actually talking about the generator currently. So we're giving students kind of a bit of a brief tour into the different equipment that's used inside the X-ray room. One of the interesting things I always like to make note of is it's sometimes the simple things when you're working on a project that take a long time. So this control panel itself was probably 3 weeks of work, deciding basically how to light it and how 3D should we make it. It's one of those interesting things when you're working on a project like this. You don't realize how long some things take. So there is 3D to this control panel. It is replicated from a real control panel. But yeah, it shouldn't have taken 3 weeks, but it definitely took 3 weeks to make. So now if I press the button here, we can shift over so that we're inside the X-ray equipment. I'll kind of give you guys a bit of an overview of the scene here. But effectively, we have a multi-use blackboard where we will present information. And again, what you can't hear right now is there's a lot of narration that is scripted and going on about this particular piece of equipment. So what you're looking at here is a very enlarged version of the X-ray tube itself. So on the left-hand side here is where electrons are produced, and they're shot over to this disc on the right-hand side at very high voltages to produce the X-rays. So let me just grab our board here and place it a little more central so you can see it a bit better. A lot of this project took place, it's been kind of broken up. So the project started in early 2019, and it's nearly done. We've gone through several developers. There's been some turnover, but we now have a really solid team that's able to produce objects very quickly. So you can see now, and again, there's electrons being produced inside the cathode of the X-ray tube, and they're basically waiting to be shot out and released by the user to form an X-ray. So you can see our information board is populated with information as we go through the simulation, just to kind of help the user understand different objects and different information that we're bringing up. The scenario is fully controlled by the user though. So although it is scripted, the user can pause it and replay certain portions if they need. So I'm just gonna hit this button down here. You'll see our electrons are shooting across and hitting our anode, which is now rotating. And then we see that X-rays are produced. So there is more to it, but I think that will give you a general idea of what our project looks like. So I'm just going to move back to my desk here. And we'll switch back to our PowerPoint. Okay, and if anybody has any questions, now is a great time. I also have Abel Waller here, and he's here helping me just to answer any questions that are more technical on the development side that I may not be able to answer.
Hi all.
Super. Thank you, Dan. Really appreciate it. That was a fantastic presentation. Any questions for Dan?
I've got a question.
Yes, Dante, go ahead.
I'm really curious because as you zoomed into the control panel and the, I forget the name of the machine you were just showing, it seemed like those were photorealistic images. So I guess my question is, what was a sort of what process did you use to produce those models?
Didn't mention them, but we do have 2 full-time 3D modelers within our team who are producing those. They aren't here. They would probably be able to answer that question very effectively, and I'm happy to pass it forward on to them. But typically they're taking photographs for reference and then creating models based on those photographs. So in most cases for the specialized pieces of equipment, it's ground up work.
Also, Dante, just to add on to that, everything is generated with Amplify. I don't know if you're familiar with that, but Amplify shader editor for PBR materials.
Cool, I will look that up.
And I see there's a question in the chat. Somebody's asking what we used for environment and workflow, and everything's done in Unity. Yeah.
Great. Was there any other questions? I can't see chat right now. So if there's any
Another
questions.
question in chat, Dan, is
okay.
Any plans for a multiplayer with this experience?
Not this one. We have a project which is planned but not yet started. That is a multi-user OR experience, operating room experience. But this one is very individual based.
Great. Any other questions? I know you are researching learner gains by use. Any preliminary info to share?
Yeah, I kind of touched on that really quickly. Oh, my video's not on. I'm hesitant to give definitive results at this time. Effectively, after 5 minutes of exposure to the sphenoid bone in VR, we're having students with no artistic abilities being able to recreate by drawing the sphenoid bone in quite a lot of detail, and a lot more detail than if they were to go through a standard sphenoid bone exercise that they might do in their regular classwork. I can't give you exact numbers of improvement right now because those numbers are still being fleshed out, but it is dramatic.
Thanks, Dan. I'm looking forward to seeing the results there. Question from Janet in chat. Were concepts introduced or reinforced by VR?
Were concepts introduced or reinforced by VR? Can you elaborate on that, Janet? Are you
Sure. Yeah, I'll do it orally. I was
Sure.
wondering, with these complex concepts, were they taught in a traditional way and then reinforced through VR, or did they experience them first and then learn, say, the formula and all that kind of stuff?
Okay, well, it's important to make note that Be the Beam has not been used in the classroom yet, although other objects have been. The plan for Be the Beam is to surround it in a complete learning shell. So the user will have preliminary and post information provided to them. And they will still be getting the regular education that they would on the process of X-ray production from a physics standpoint. And that's all being delivered through our online platform. We call it the Learning Hub, but it's effectively D12 Brightspace. So we have an LMS that's presenting this information before and after. So there's no new concepts to them. Hopefully that directly addresses your question. There's no new concepts given to them in VR specifically. It's a reinforcement.
Thanks, Dan. Question from Brian. What other functionality or student tasks are planned as part of the project going forward?
Yeah, so the project goes through a few stages. So the stage that you saw was the X-ray room. We could have walked around it, but I didn't have time for that. And the second stage is going inside the equipment. So what you were inside that you saw was the X-ray tube where the X-rays are being generated. But the process follows through with those X-rays going through what's called a collimator, which effectively filters out certain types of X-rays. And at that point, we allow the students to actually adjust the dials and the knobs on the collimator to change the shape of the beam, if you will. So if you've ever had an X-ray and you get the light target on you and they kind of move that around, that's exactly what the collimator is doing. And that's what we'll have our students do. And then after that, the students will follow that beam through the patient. So we'll be going inside the patient, we'll be seeing their bones, seeing the X-ray hit their bones and be absorbed in some cases, and in some cases go through to the receptor, which is, we'll do a bit of a, well, I say a bit, we'll do quite a deep dive into receptor technology because that's where a lot of physics is taking place. When we take the actual X-ray and translate it into a digital piece of information that we can represent with an X-ray at the end of it.
Great, thanks, Dan. Any other questions for Dan? Okay. Thank you so much, Dan. Really appreciate the presentation. That's excellent work. I think also like to give you a shout out and to Jennifer and Francine and the School of Health Sciences at BCIT, because this project also won an award in 2019. So congratulations on that as well. Moving on, it's my pleasure to introduce Jennifer and Chris, also from our Learning and Teaching Center team at BCIT. Jennifer is an instructional development consultant and has been very, very committed to our virtual and augmented reality program. She works as part of our PRISM team as well, as does Chris. Chris is our video and digital media producer, and he has been very active in this field, including in the development of 360 VR videos. And I'm really looking forward to hearing their presentation. So over to you, Jennifer and Chris.
Thank you. So Chris is going to upload the presentation.
Okay, give me a second to share the screen here. Hopefully this will work. All right, I'll just...
Looks good, Chris.
All right.
Thank you.
That's good to know. All right.
Yes, we really enjoy this template that we're using. So welcome to our presentation on assessing coastal sustainability using 360 VR images. Our objective today is to demonstrate how we took a face-to-face class and replicated an authentic experience using 360 VR images. So I just wanted to take a moment here to introduce myself. My name is Jennifer Madigan, and I'm an instructional development consultant at BCIT. And I have here with me my good colleague, Chris Cambone, who's a video and media digital producer, and as well as David Harper, who couldn't be here today, and he's instructor in natural resources and engineering. So I'm just going to take a moment here and pause and let Chris introduce himself.
Thanks. As James mentioned, I'm one of 3 video and digital media producers at BCIT. We do everything from instructional to marketing to informational content in all sorts of formats. Of course, we've been doing a lot of VR content and probably in the last 10 years. And when I mentioned VR, we are doing basically 360 VR, basically taking still images or video and wrapping them into a sphere that people are able to look in all directions, or what we call 3 degrees of freedom. And of course, with COVID, we are now doing quite a bit of work replacing traditional learning environments or off-site scouting, that sort of thing. So I think at this point, I've probably got 11 to 12 different projects on the go for VR training content. Let's go to the next slide here.
So the project came to us through the Stewardship Center for BC Green Shores for Homes. And BC Green Shores for Homes is a voluntary incentive-based sort of rating program that focused on positive steps to restore and protect shorelines. So originally, sorry, next slide, please.
Okay.
Originally, the workshop required participants to travel to an island, and it was constructed in a face-to-face environment. Then they were required to walk along the shore and identify potential barriers that could affect and damage shorelines. So barriers could be things like a dock or a berm or a seawall. And then they were required to draw and identify sort of the potential hazards and attribute a Green Shores credit to them. For example, if one were to remove a seawall and replace it with gravel or boulders of vegetation, as you see here in the picture, that they would get a certain number of credits that they would then apply to receiving a Green Shores qualified home. So based on this, what Dave wanted to do was he wanted to create something that was virtual that would allow accessibility to more people and allow people not to travel to islands because sometimes it was inaccessible. So if we could go to the next slide, please. So Dave's needs were to sort of replicate a field scenario where course participants could observe various physical features of the shoreline and sort of manipulate objects and get a better understanding and perspective of the site in order to make improvements. So this includes being able to identify and observe and assess position and size and sort of the lay of the land and the slope of the property. So he realized that in order to do this, he would need to take a lot of pictures and a lot of videos from different angles in order to create the virtual walk. And so Chris and I thought about this and analyzed some of Dave's needs, and we thought about how we could actually replicate this. So there were a couple of things that we needed to think about. Sorry, the next slide, please. One was we needed to create an environment that would allow for enough free exploration. So we wanted to really give the learner a sense of control in the same way that one could walk along the shoreline and look at things from different angles. We wanted to be able to replicate that. We were really cognizant about the amount of sensory input that the learner was exposed to construct meaning out of the exercise. And also we really wanted them to look at the object and reflect on it and make that connection between the object and the Green Shores credit system. And so Chris suggested flying drones over Kate's Park in North Van. And that was quite interesting because we had to time the tides and we also had to dodge out of pictures and so that the drones didn't capture us. So I'll give it over to you, Chris, and you can explain some of that process that we went through.
Okay, what I'll try to do first is actually, just so everybody knows what we're actually talking about, is try to quickly show a demo of the final results, which opens up in a web browser. Hopefully this will work for you. So let's see what this does here. Let me know if you can or cannot see that. Everybody see that?
Yes.
All right. Yes. So it opens up with initial interface with some instructions for the student on how to navigate through this. So basically, this may not move smoothly on your end, but the user is able to look in all directions, up, down, 360 degrees, basically. So what Dave wanted me to do is recreate 3 different scenarios at a beach in, well, I call the Deep Cove area of North Vancouver. So you'll see on the left side here, we have the 3 different scenes. I can click to each different scene quite easily through thumbnails. And I'll go back to the first one just for an example here. So basically we have hotspots. When the student clicks on certain objects of certain color, and there's a chart on the bottom to see what those objects are related to, you get a little more information. And it could be anything from, that's an aerial shot we took to get a better view of the shoreline, to something that's a little more just basic information about what they're looking at and how to evaluate it. So another thing, another way to navigate is through things like we've placed basically markers on the ground that a student, if they click on it, will virtually push them to the next location. People are probably used to seeing this sort of thing in virtual house tours. So we've sort of taken the concept and expanded on it. And they can basically move up and down the beach, look in all directions, and do a virtual inspection without, you know, getting your feet wet, so to speak. All right, I'm just going to get out of that for a sec. I'll hide that. Let's see if we can go on to the next slide. Now, the equipment we use for this, as far as VR cameras, 360 VR cameras, they come in all sorts of different sizes and flavors. This one is sort of in the higher end range. It's basically 6 high-resolution DSLR cameras inside this sphere, all taking images at the same time, and the camera will basically what's called stitch them all together into a image which gets wrapped around a globe. So in real time, we can show the client, whoever it is, on an iPad, the actual VR within, it takes about 30 seconds for it to render out. And we're able to tell whether that's working for them or not. And for the beach, Dave actually laid out a grid where we moved the camera about every 10 or 15 feet on a grid along the beach up, you know, all the way from the shoreline, all the way up to people's properties, and covered, I think we did about 60 or 70 in total, I'm not sure. Anyway, we were able to use that in case we wanted to map the location and put GPS markers on it that people could basically click and get a view of where these cameras were located. But in the end, we didn't need all that information. So what's great about these cameras is they're fairly easy to use. Like I said, go from 2 lenses all the way up to 10 lenses. They also do 3D content, which we've done on occasion. And 3D is different than 360. 3D is basically the space between your eyes, and it replicates that to make things look 3-dimensional. Does HDR panoramas, that sort of thing. Another thing that's critical with this sort of capture is it also does 360 audio, which people forget is very critical, especially in training scenarios for accident recreations, where you may have the noise of something behind you coming towards you, a loud truck or something, and it forces the user to turn around and look in that direction. So you have to keep in mind that audio is just as important as the visuals with this. Of course, we can do video and stills with these cameras. And of course, as we mentioned, my department, media production, uses drones quite a bit, or remotely piloted aircraft systems, as Transport Canada calls them. We have, you know, tiny ones all the way up to very large, heavy lift ones. But for this application, we needed just a fairly high resolution camera and the ability to hover, which we're able to do with this camera. And what's good about this particular drone, which is used a lot on film sets, is we're able to swap lenses out for sort of wider, closer shots. If we're in a dangerous situation where we need to be far back, we can put a zoom lens on it. Also, we'll do FLIR or infrared cameras, multispectral cameras for crop inspections. We can actually attach things to drop payloads, you know, even small defibrillator kits, that sort of thing. But for the Green Shorts project, it was basically GPS tagged aerial shots. Of course, the software we used to do that, and there's quite a few different softwares for doing 360 VR authoring. We use 3D Vista Virtual Tour Pro, which is was originally used for sort of real estate stuff, but they've gotten into the educational field, so you're able to embed quizzes and that sort of thing into it. So, you know, we're able to drag as much content I can get into it, add hotspots that can be anything from, you know, obviously photos, 3D objects, websites, PDFs. There's a huge list of things that can be added to this software. And what's good is when with the software, what's excellent is when you go to export it, you can export it to multiple formats. So obviously we can go to web format, we can go to headset delivery, which is obviously going to be much higher resolution and a little more immersive. There's also the option to create mobile device versions, which people often forget about, because a lot of people are doing these sort of things on their mobile devices. I think, Jennifer, if you want to continue from there.
Absolutely. So the key to this exercise was really giving the students enough confidence to correctly identify the Green Shores credits and apply it to their future projects, and allowing for that transfer from the VR world to eventually the creation of a authentic artifact. So you see here in the pictures, this is something that was done before, where these walls are a barrier to sustainability and then replaced by an ecosystem that allows for sustainable shorelines. And the students really embraced this interactive experience and found it very engaging, and they were really looking forward to more VR training in the future. And the best part, of course, was how accessible it was without taking a ferry and waiting for those long ferry waits.
Yeah, and then one thing I should mention that the users don't have to download anything, no additional software. It'll open up in almost all browsers. So it makes it very accessible for everybody.
Yes, absolutely. And yeah, so if we have any questions, please, we're here to answer them.
All right. Well, thank you, Chris and Jennifer. That was fantastic. Any questions for Chris or Jennifer?
I thought there'd be more drone questions.
Yeah, no question about the drones or the project.
I'm the only guy that gets excited about those things.
Okay, question from June. How long did it take you to take 360 images of the scenes and stick them together?
Okay, the actual shooting, it's basically like taking a still shot. So it takes literally seconds to take the images, and probably another 15 to 30 seconds for it to have a view of it. And like I said, there was probably 50 to 60 or even 70 shots we did over that one day. So again, the challenge is you have to get out of the shots in 360 images. People forget that. It's not like a traditional camera where you can just hide behind it. So it got pretty funny because we'd be in the middle of this beach and I'd put the camera on a timer and we'd have to run like a bat out of hell to get hiding behind a pole or get into some bushes or something and do this multiple times over. So it probably took an hour to do those images. In post-production, because of the interactivity and embedding of additional content, that took me probably 2 or 3 days. And then we're another probably a couple of weeks of just tweaking elements. And the good thing about the software is we can continually update the show, so to speak, in the background, and user doesn't notice it in the back end. That doesn't change their URL or anything. So yeah, it's probably the shooting of the VR is actually the easiest part. It's the sort of the post-production adding interactivity takes a little more time.
Thanks, Chris. Question from Saeed. Do you know if the platform is FIPA compliant with privacy legislation in BC?
The 3D Vista platform?
I think so, yes.
Yeah. Well, that's the thing. I mean, the servers that we use for that are actually hosted outside of North America. So that may be a challenge. We have the option to host ourselves, but there's some technical issues with that. So that's something we are actually working on, and we've been discussing that issue at this point.
Okay. Question from Brian. Chris, can you talk about other 360 VR projects you have worked on or are planned?
Okay. I've done everything from a construction safety officer training video, which basically we got into a building site normally the students would be able to go to, but couldn't. Took a bunch of, recreated some accident scenes. This is with video. So now students can do a virtual training. They've done some stuff for the School of Health, virtual versions of a nurse, inspecting a patient, so to speak. I just shot some footage up in a quarry in Abbotsford for a mine manager course. But geez, there's a whole bunch more than that, and I should have brought those in front of me.
Chris, we did one on finances and what was it? Fixed and variable costs. And so Chris went into different departments, and let's say you're looking at like the auto shop, for example, and then there's a bunch of rubber on the floor. So is that a fixed cost or a variable cost? So that one was a really interesting take. Yeah, and we went down to Gishon Creek too. So
yeah, that's true. And I've done even done a virtual tour for nursing students at the BC Cancer Agency, which is very difficult to get into. So having a virtual version really worked out well for them. Lots of hotspots and additional information in that. And I've done quite a few more than that.
Welding, auto body.
Yeah, I've done a virtual tour of the welding shop, auto body. Pretty much, I'm working with our BCIT's marketing department right now to do not necessarily virtual tours, but virtual experiences, they call them, showcasing areas that where 360 VR content would really bring it alive. So there's a big push for that now, especially within the marketing department.
Great, thanks, Chris. Question from Kyle. Is the Insta360 2 Pro, is it usually mounted on a tripod, or did you have the remote control base? Also, is it possible to remove the user in post?
Well, actually, one thing I didn't mention, that we actually had that on it was on a stand, basically a small tripod system that we're able to up, lower in height, and it's out of the leveler on it because we want to try to keep it fairly level, though you can do that in post. And as far, what was the second half of the question? Sorry.
Oh, he was curious if it's possible to remove the user in post-production.
Yes, with still images, it's basically like taking the image into Photoshop, which you can do. You can take the stitched image into Photoshop, remove and manipulate anything you want. When it comes to video, you can do it, but it's very difficult. You'd have to go into something like After Effects and digitally remove them. So yes, it can be done. A lot easier with stills and a little harder with video.
Okay. Question from June. Any challenges from an instructional design perspective, and any tips for others who might want to do similar projects?
I think the challenge was really need to know and nice to know, as instructional designers all know that this is a big deal, and just really separating what the learner actually needs to know in order to attribute the necessary credits, and what was really nice to know and fun on a VR sort of VR world, right? So, you know, sometimes we get carried away with the technology, and we really have to ask ourselves again, what is nice to know and what is need to know, and work with the instructor on that. So.
Yeah, and the other challenge is explaining to people what type of VR it is that we're doing, because when you say VR, people assume it's like gaming, interactive. You can walk, it's what they call 6 degrees of freedom. You can walk to something and you can touch it. There's augmented reality. There's so many versions of VR that gets confusing. So my challenge on my end is explaining to people what 360 VR is, how good it is, because it's very fast. It's very, I mean, I can literally shoot something and have it online within an hour, but we're limited into, you know, having the interactivity as far as moving within a shot sort of thing. So, but we're working with that. People are slowly getting used to what we mean.
And another challenge too is sometimes if instructors don't understand the technology, they come to us with these really grandiose ideas, and it would take like the whole EA team to actually get it done. So it's helping and educating the instructor on the technology as well, and what is possible within our learning environment.
Great, thanks. Another question from June, and June, please keep firing them off. Great questions. What is the budget for this project?
I'm kind of laughing because I come from the corporate world where everything is budgeted. This came from the School of Construction, and they were responsible for the budgeting of it. So we actually don't know what it was that was done on their end. So sorry, June.
Yeah, I mean, a service on our end is, I mean, from our department, our service is free, but it's additional cost if we have to get stock footage or we have to hire narrators or actors or that sort of thing. But in this one, there was, I don't think there was any of that. There was a little bit of overtime and that sort of thing, and it wasn't a big expense or very little expense for the School of Construction.
I have a question for you too as well. Just building on the theme from the two previous presentations, is there any anticipation that you might be doing some research in this project as well to see about the effectiveness of the tools?
Oh, James, I'm always looking at research projects, right? So definitely, Chris.
Great. That's good. I think it's really, especially as we're exploring innovative new techniques and technologies, I think it's really important to have some benchmarking to see if it does actually make a difference in the classroom, because these things are costly, they do take time and energy, and it is challenging for instructors to use them. So if they do have a strong impact, I think it really justifies a lot of that. So the question also or a comment from June, great project, and he can see JIBC doing something similar, and he may be reaching out to you a bit later. Any other questions from the group today? Hearing none. Okay, well, thank you all for joining the webinar today. I'm so glad to see all your faces. Look forward to having face-to-face meetings again in the hopefully not too far distant future. So thank you all. If you have any questions for myself or the presenters, feel free to reach out, and I'll look forward to seeing you at the next one. Thanks, everyone.
Thanks, everyone.